To take the derivative of cotangent inverse of x, we can do it like we've done the derivative of all of the other inverse functions of the trigonometric functions. So, taking the derivative of cotangent inverse of x, we can say let that equal y. And solving for x, we get that cotangent y is equal to x, based off swapping the inputs and outputs to get the original function. So get rid of the inverse and swap the inputs and outputs and get this result. Using this equation, we can take the derivative of both sides with respect to x or y, in this case with respect to x. So taking the derivative with respect to x, we get that the derivative of cotangent of y with respect to x, well, in this case, we'd have to use implicit differentiation. So the derivative of cotangent we know is negative cosecant squared. We saw this in a different video of why this is the case. But of course, we'd have to multiply the derivative of the inside of the function, which is y. And we're differentiating with respect to x, so we get dy dx. And of course, the derivative of x with respect to x is 1. Now solving for dy dx, by dividing both sides of this equation by negative cosecant squared of y, we get that dy dx is equal to negative 1 divided by cosecant squared of y. But what is cosecant squared of y? Well, using this identity, we get that cosecant squared of y is the same thing as 1 plus cotangent squared of y. And cotangent squared of y, we said was x, so the final result, the derivative of cotangent inverse of x with respect to x is equal to negative 1 divided by 1 plus x squared. So this was differentiating with respect to x. We can also differentiate with respect to y, like this. Doing so, we don't have to use implicit differentiation. The derivative of cotangent of y with respect to y is just negative cosecant squared of y. But here we get dx dy, but we want dy dx. So we'd have to reciprocate both sides of this equation to get dy dx is equal to 1 divided by negative cosecant squared of y. But again, what is cosecant squared of y? Well, it's 1 plus cotangent squared of y. And cotangent squared, or cotangent of y, is equal to x. So this is the same thing as x squared. Or in other words, the derivative, again, of cotangent inverse of x is equal to negative 1 divided by 1 plus x squared. Another way to do it is to use this theorem, or this formula. The derivative of some inverse function is just equal to 1 divided by the derivative of the inverse function, the derivative of the original function of that inverse function. So let's try using this formula. So again, starting here, cotangent inverse of x is equal to y is equal to f inverse of x. Well, if this is true, we can say that cotangent of y is equal to x. Same thing how we did over here and over here. But even more so, we can say that cotangent of x is equal to f of x, because we know f inverse of x is equal to cotangent inverse of x. So the original functions, cotangent is equal to the original function, f of x. But we don't want f of x, we want f of y. So we can say f of y is equal to cotangent of y, and take the derivative of f of y, because the formula says that we need f prime of y. So f prime of y is equal to, well, what's the derivative of cotangent? Well, we know that that is negative cosecant squared of y. We figured out the derivative of cotangent over here as well, and over here. So we get that the derivative of cotangent is negative cosecant squared. And now plugging it into the formula, the derivative of our inverse function, in other words, the derivative of our cotangent inverse of x, is equal to 1 divided by f prime of y. So 1 divided by negative cosecant squared, just how we got over here. But what is cosecant squared? Well, it's 1 plus cotangent squared. So this is 1 plus cotangent squared. And of course, cotangent squared is just that x squared. So again, we get the derivative of cotangent inverse of x is equal to negative 1 divided by 1 plus x squared.